All right, we're going live. See when we connect. Today is going to be a pretty cool stream. All right, cool. I can see myself now. So, hey, what's up, everybody? This is Jesse from BCC Board Repairs. Thanks for joining. Today I'm going to do a quick video on how to fix an iPhone 7 that has a backlight issue. So, it's going to be a pretty quick stream. So there's going to be a lot of information about how to diagnose the issue, what things to check, how to use your multimeter on to check for diode mode, see what's the issue. So hopefully it's a pretty straightforward repair. I haven't looked at it too much, so I don't know what I'm getting into, but I'm assuming it's a standard backlight repair. So so I see there's 2 viewers have joined. Welcome, guys. I see Jose and Clan42. What's up, guys? So let me go ahead and switch over to the other camera. Okay, so this is an iPhone 7. Oh, what's up, Justin? Let's see. Let me adjust the window. All right, so this is an iPhone 7. One of the first things you want to do when checking for backlight is plug it into charge. So you plug it into charge. You can see my USB current here on the screen. It is at 0.9. That means it's charging. Usually anything close to 1 for the amps, your charging amps or charging current, will be something close to 1 amp. So you can see I unplug it. Actually, let me restart it so you guys can see from a dead battery. Right, so a lot of people misdiagnose this issue for no power or no image. So there is a way to tell the difference. So one easy way is check your charging current. So right now you can see we're at 1 amp basically. If I turn on the chart, you can see it's a solid 1 amp charging. So the purple line on the graph is the charging current. So you can see it's close to 1 amp. So that means it's charging. If it was something really low, then maybe it's not powering on, maybe it's not charging, maybe some other issue. But yeah, so that's one thing you want to check. Let me go ahead and stop that. And then the next thing you want to check is actually look at the screen under a light. Can you guys see that? It says hola. It says hello. So you can see the phone is turning on. And you can even see the touch working. So that's, you turn off the screen, turn it back on, you can see phone is functioning. There's just no backlight. Backlight is literally a light that's behind the screen, the image that lights up the display. So it's pretty common for that to fail. Either it's a technician who didn't unplug the battery, you're replacing the screen and you have the battery plugged in and you're trying to align it, and then you basically short the wrong pins together through that process. Also, I'm testing with the known good screen. So this screen I have on right now is my OEM screen. I like to put little happy faces on it just to make sure I have a known good screen. This is the customer screen, so it's not a parts issue because this is the screen I always use. And yeah, it looks like somebody restored the phone. So sometimes repair shops who kind of they run into problems, one of the steps they do is restore the phone, which probably wasn't necessary, but if you put your phone in recovery mode and you start the update process or restore process, you should get image at some point. So if you're not, then it's a backlight issue. Okay, so we pretty much narrowed it down to the backlight just because you can see the image, you just can't see backlight. So I hope that part is clear. All right, so let me go over to the board. So right now, let me move this out of the way a little bit. All right, so this is the board. You know, when you have a backlight issue, you know, where does the backlight come from? You know, one of the things you always want to start off at is, you know, the backlight comes from the connector where you plug in the screen. So that's kind of where you want to start your inspection. So this connector here is the LCD display connector. So, and then this is the home button. So let me peel these off just so we can get a better look at the connector. So as of right now, I do see something pretty weird, which I've never seen before. You guys see that scratch right here? I don't know what they were doing. I'm guessing, oh look at that, thing's loose. I'm guessing that the technician was probably changing the screen or something. The tool must have slipped and they like damaged the board. So let's go ahead and take a look at what that is exactly. Let me minimize this. All right, so here I have the iPhone 7. Hold on, let me just double check. Is this Qualcomm or Intel version? I hope it's Qualcomm. Yeah, this is Qualcomm. So let me go back. One quick way to check is check the baseband PMU, which is right here. You see it says Qualcomm. There's two versions of this iPhone, and they're slightly, the main difference on the board is this area, but also I've seen some minor differences here, like by the connectors and stuff. Just like some components are just like different spots. Okay, so this is the oh sorry, forgot to change the view. All right, so this is the, let's see if you guys can't see. I'm trying to adjust the view so you guys can see the, there you go. So you guys can see the line. So at the bottom of the screen, there's a little pop-up that tells you the name of the line, PP LCM BL anode con. So in short, what that means is the power rail for the LCM. LCM means image, and BL means backlight. Anode is, you know, one side of the backlight circuit, and con means connector. So basically this means this line is the one connected to the backlights. Like this side of the circuit is on the connector side. Let's take a look. So I have a suspicion this is what's causing the issue. So on your multimeter, if you have the Fluke 115, this is the one I would recommend, just because when you put it in diode mode, so that's this setting, this is a little diode icon, the little white one. When you put it in diode mode, there's some benefit to it, because on this one, because it beeps at you when it gets a reading. It also beeps when there's continuity. So basically in diode mode you could do almost everything. So in diode mode, if you touch them together, it beeps, means probe red is touching probe black. You know, so if you touch one component and then touch another component and it beeps, it means those two components are connected together. Now diode mode, it gives you a value when you measure. So you put your red probe, if you're looking at, maybe I can change my camera. So if you put your red probe on ground, generally ground is something metal, or you could refer to ZXW. So like this, this chip right here called Trinity, or like this screw post or the metal shield. Anything metal is generally ground. So if you touch anything else that's ground, you'll hear a beep. Okay, ground, ground, the side of the shield, ground. So put your red probe on ground, and then if we go back to the other view, we're going to try to measure that point, the one on the ZXW software. So if we touch that, we get OL. So we can move closer. You can see there's a pin on the connector that is also red. So we touch that, we get OL. By the way, if you're watching, make sure you do me a favor, support the channel by smashing that like button. If you're not subscribed yet, please subscribe as well. That way you could get notified when we post more videos. So we show up on your feed basically. So yeah, there's this pin, this test point that connects to this pin. You can see there's OL. So in general, what you would be doing is you want to measure each pin here at the connector to see if there's any issues. So just from experience, I know this bottom right side is the backlight circuit. So if we look up close, we have PP, LCM, BL, again, BL for backlight, Cat2, that's the cathode. Well, this is the one we already mentioned. We have another LCM BL, which is backlight Cat1, AP to LCM resets, Mamba to LCM. These are some other lines, but in general, these bottom right pins are backlight. If you go look at the other pins, there are other stuff. So this is image data lines. They're called MIPI, AP to LCM. Just reading the name of the line kind of gives you a clue as to what could be what it does. Some is a little more cryptic. So this one says SPI to touch, SPI AP to touch something. So this is probably touch related. So if you have touch issues, you could probably look closer at these lines. If you have image issues, then you're probably looking at these power lines, 5V7 LCM. So if you're not sure, there's an issue with the display, with the screen, with something showing on the screen. So what you can do is, where am I? I'm gonna come down here. So what you can do is just measure the whole connector. So let's just go through that practice just so you guys can see what it's like. So let's start off with this bottom row. So we can see there's like this white number with red text, a white box with red text. That is the diode mode value that ZXW provides. It's not always accurate, but I would say it's 99% accurate, so that's good enough. So you put red probe on ground. So I'm putting it on, look at the bottom of my screen, on this metal chip. Let's do it on this metal post, screw post. That way you guys can see a little better. And then I'm going to touch with my black probe each pin. So you do have to have some fine tip multimeter probes, which I do have linked in the description, and they're universal. So I'm touching the first pin on the bottom left, and we get, my meter says 0.538 volts. On ZXW we get 0.497. So it's pretty close, so we could just assume that's good. The next one is 0.600 when it should be 574. That's pretty close. The next one we get 1.463, which is a really high reading. Here on ZXW it says, I don't know, 0.62, and then it says OL. I don't know exactly what that means, but lucky me, I do have it's not a good board. So just for comparison, what you can do is grab a known good board. So this is another iPhone 7 board. So if you're ever not sure, just compare it to that one. So we're looking at pin 3. Well, not pin 3, but the third pin here. If I measure that, I get the exact same reading. So we could assume that that pin is supposed to be 1.4 whatever. And one thing to note is that every multimeter will give you slightly different readings. So you know, like my meter can give a slightly different reading than your meter. So it's something to keep in mind. Alright, so this third pin, let's go ahead and continue on down this path. So this third pin is at 1.465. Next pin we get 0.347, which is on ZXW 0.3, so that's close enough. 0.534 should be 712. Let me see, what is the line called? PP1V8 touch. So we saw touch was working, you know, at the back, even though the backlight was out, we can see touch was working. So let's just go ahead and assume that's fine. Alright, so where was I? So I know 3 is a weird number, and then we get 0.3, and we get the big variation number, so 539. Then we get 503 or 536, and the reading should be 503, so that's close. 474 and 429, okay, that's fine. So you can see, just go down the row, and then here's a ground pin. So ground pin will beep at you, and what I like to do is actually use the ground pin to kind of remind me, you know, where I left off. So if I ever like had to stop and do something else, then I can always just start off at the ground pin. So just kind of probe around, like, okay, this is ground. Okay, so we know the gray pin is ground. So we know the one to the right is going to be OL. So ground, OL. Next one's OL. So it helps you kind of, you don't have to start all the way to the left, or you don't have to count, you know, I'm on pin, the 7th pin, so you have to count, you know, 7 pins down. You can just use a ground pin to kind of help, you know, find your spot in the connector. So I'm at the first one after the 2 OLs, which is 552, and I'm getting 762. It's not too far. I mean, that's kind of a big gap, like over 100, 200. But let's just go ahead and keep on going. We want to look for something bad. So either a ground, so like 0.000, or an OL when we should get a good reading. Okay, 473, 480, and OL. Right, so we're at this pin now. Let me scoot this over. All right, so OL was what? This one? No. That's 1, 2, 3, 4, 5. So yeah, so I'm at OL, the 5th one from the left. I mean from the right. And then we get 426. And we're supposed to get 589, right? And then we're supposed to get 504. Wait, what's happening, right? We're supposed to get 504, but there's OL. So this is kind of where you would get a clue as to what's happening. You would, you know, you're probing around, you expect a reading, and then you get an OL, or you get a short. So like, let's say you're supposed to get 504, and you probe the pin and you get something like this, like 0.000. That means you have a short. So something in that circuit is shorted to ground. But in our case, we have an OL, which is the opposite of a short. You have an open line, you have a disconnection somewhere. These pins go through, a path to something else, and usually there's components that kind of bridge one side of the circuit to the other. So the filter, sorry, I'm kind of jumping ahead. So there's usually a filter that bridges, one side of the circuit to the other, and a lot of times those fail. So they fail, it disconnects. So now this pin on the connector does not reach where it's supposed to, where it picks up a reading. So anyway, long story short is this is our problem right here, which we kind of had had a clue because remember this something happened here. So let's take a look on the other side to see what's going on. Let me drink some water. I did a lot of talking. Hey, what's going on, HP and Peter? Thanks for joining. You guys will have to, well, Peter, you have to go back to the beginning and watch, see what you missed. All right, so let's get back to ZXW. So we know this line is the issue. Now the question is where is the problem? So what you can do is on ZXW, if you hold Control and click the right arrow. Oh wait, hold on. Here it goes. So hold Control and click right. It'll jump you to the next position or next component or connection. So there's only two on this side. If you push Tab, you now jump to the back of the board and do the same thing. Control. Oh, you guys can't see it. So there it is. Probably too zoomed in. So if you touch Control right, you can see it's picking up, showing you where those components are. So these are all on the same circuit. So basically, the way to think of it is like the road from the connector to whatever it's supposed to be connected to starts off at the connector, probably through that test point, the little circle where it's scratched, and then it goes through the layers to this side, and then this component here that says FL3901, that is probably the problematic component. So let's go take a look under the microscope. So that's here on the back side. All right, so let me move this out of the way. Let's put it here. So if you compare this part of the board with this part, you'll see we're working here at the bottom section of the board, which is this. So now you gotta find that component. So so it's the second one down from this little area, and basically very top right, and you go down one component. So this one, right? So thing is, these components are covered by underfill or coating, or I don't know what you want to call it. But you kind of see a little something here, right here. So let's go ahead and get rid of this coating or underfill, so we could see, like, we could get a better look at it. So I have the board on my preheater. My preheater is a PPD 120, and it's set to 120 Celsius. I'm gonna go and put my hot air super low at like well, not super low. It's going to be at 250 Celsius and 65 air. I'm just going to go ahead and clean off all this stuff around it. I'm using an X-Acto blade to gently pick off all this stuff right here. So I'm using very little amount of force, and just kind of cleaning off the area. So with this low temperature, you don't have too much risk of damaging anything, but you know, just also you want to be careful anytime you're using your hot air. You got to be mindful where you're pointing it. All right, so here is that second component, and it's kind of hard to see, but it's actually it's like burnt. So here, let me clean off a little more of this underfill stuff because it gets in the way. I see there's 9 people viewing. Thanks everyone for watching. If you're new here, make sure you subscribe to the channel. If you like what we do here, it'll really help us out. And YouTube. Hold on, let me restart it. Strange. Actually, a few of the cameras stopped working. I'm not sure what to do. Hold on, let me see if I could restart this. So I'm gonna unplug my camera, plug it back in. So weird. Literally just died on me. I don't think it was the cameras. I think my USB and my computer messed up. Let me try something. Sorry about that, guys. I have no idea what just happened. Oh, there it goes. Alright, fix one. Where did this one die? Alright, cool. Any other ones? Oh, this one died too. Yeah, there it goes. Well, that's cool. Alright, cool. So I got this fixed. Alright, so this was the component that ZXW pointed me to. And you can see is like, it's hard for you guys to see, but this thing is charred. Where'd it go? Yeah, well, I just lost it. But like I was mentioning earlier, when you get an OL, what that means is, like, the way I like to describe it is there's like a bridge, right? So we have the bridge, like one side of the bridge is the connector, and the other side of the bridge is, let me close device manager. Right, so one side of the bridge is like this connection, so from here to here, and you know, this side. Then the filter is like a bridge, and if that bridge collapses, now both sides of town cannot reach each other. So that's kind of one way to think of it, or just think of it like a cable, right? Like an extension cable, and the two extension cables disconnected. Now, you know, one side is hot, you know, there's a connection, and the other side is it's the loose side that had no connection to anything. And that's one way to think of it. Another way, like Christmas lights, some Christmas lights, if one light bulb goes out, the whole, like one side of it goes down. That's kind of what happens here. So this filter is like a little bridge from this side to this side. So what that means is right now we're getting OL diode mode reading on this side. So take a quick look. Let me see if I get this to focus. Yeah, since my camera shut off, it stopped focusing. Let me fix it. Alright, so if you remember at the connector, I got OL on this line. If I were to probe anything else on this line, so there's not even a cap. So alright, so just here on the left side of the filter, a tight spot, so you gotta get creative. See, I'm touching, well, you guys can't see, but I'm touching the left side of the filter and my meter still says OL. I touch the right side of the filter, look at that, I get a reading. Now the reading is going to be way off because I'm on a preheater and the heat changes like the resistance of stuff. So here, let me take it off and cool it down. Meanwhile, let me take a drink of water. Alright, so we're 32 minutes in. We got seven viewers. It's actually midnight here in Las Vegas. So I like to work late at night. Alright, so let's take a look at this again. So I'm basically just repeating myself in different ways to say the same concept in hopes that it kind of makes easier to understand what I'm trying to explain. So with the filter, if it goes bad, what you'll see is one side is OL and the other side is the reading you're expecting at the connector. So here on the right side of where the filter was, we get 4, 56, 57. So it's basically going up because the board is so hot. As soon as the board cools down to room temperature, you'll get a very close reading to what ZXW was saying, which was 504. For some reason it says test point 495, but you can see it's only like 10 points difference. So that part doesn't matter. So basically if you diode mode every component on a working board, actually I have one here. Right, so what I like to do is oftentimes probe every component. So you see I'm touching so this is a known good board. We're getting 532, touch that test point, 529, flip it over. Oh, well, problem is this stuff still has the coating underfill, so let me go ahead and kind of take it off. So I touch the left side of the filter, 520, touch the other side of the filter, 519. So you can see, like, I can just keep going down the path and I'll get very close reading because it's all the same path, it's all connected. So the diode mode reading should be there anywhere along that path, and it should be the same or similar. So let me get rid of this good board and get the customer's board. Right, so here we go here, do the same thing. we touch the connector, OL. Test point, OL. Left side of the where the I'm touching something else. Left side of the filter. Oh, there you go. Touching that. I get OL. Touch the right side. There it is. There's the reading I'm looking for. So if I add a filter, it'll just reconnect all those other OLs back to normal, basically. So I hope that makes sense. It's a little. It could take a little while for it to click, but once it does, it'll make things a lot easier. So let's go ahead and get this actually fixed. So what I'm gonna do here is first we gotta tin the pads, which means add some new solder. Helps when you're soldering another component back on. If you leave the factory solder, it's sometimes dirty or it's like hard to make a connection. So using my micro pencil, was a really tight spot. Alright, so just put some solder on your micro pencil and just basically adding little balls of solder to the connections. Clean this up. You want to clean up the old flux because it tends to like burn up and then hard to solder on. So you can see there I have added some solder here, and then there's like a little nub here. Looks like the pad kind of blew up with the filter, with the one that went bad. So you have to keep that in mind. Let me clean up some of the stuff around it so it doesn't get in my way. Alright, so now what filter do I use? So in this case we're dealing with this is a 33 ohm 1500 milliamp 0201 filter. So if you're not sure, easiest thing to do is get a donor board and grab it from there. So let's just do that. So this is the one I was measuring earlier, and if you remember, I got a good reading on both sides, so we know the component's good. So first what I'm going to do is put my board on the preheater and then just clean off the underfill. So technically I could grab the one at the end because I think they're the same value. So if we go to DXW, you know, there's three filters here that look identical. Sure enough, 33 ohms, 1500 milliamps, 0201 package size. They're all three of these are exact same values. So I could, to make it easier, you can just grab the one at the top, because that one's, you kind of have a little more room to work with as far as pulling it without like losing it or messing up everything. So this board I'm pulling it from is just an iCloud locked board, what we call as a donor board. So you're basically harvesting components off of it, like a donor person, I guess. I don't know where that name came from, but it's a parts board. Alright, so I like to clean off as much as this coating off of it. Otherwise, when I remove it and transfer it to the customer board, then oftentimes that stuff gets in the way and it makes it harder to solder back on. So here's how I remove it. It's a little trick I kind of figured out. Is first I put some solder on the tip of my iron. I tin both sides of it. I'm adding my own solder just because this solder that I use is lower melt. And then I go to my hot air at 365 Celsius, and I use both my micro pencil. There it goes. So I was able to pick it up. If you see here, I have it on the tip of my iron. So I hold it, I swap out the boards. Focus. So I try not to move too much with my right hand that has the iron and the filter. I don't want to lose it. So using my tweezers, I help align the components. And I think I got it. So it's kind of looks a little crooked. Let me see if I could straighten it out with some hot air. So I'm just gonna, I gotta move fast because, there you go. Oops. I like to move my hot air fast just so it doesn't concentrate the heat in one spot for too long and then kind of mess things up. You know, the heat can soak through to the other side, cause some other problems. So I'm gonna take the board out of the preheater. Let's see, where's that? Alright, it's been about maybe like 30 seconds now that I took off the hot air from it, so obviously now it's safe to scrub it with some isopropyl alcohol and blow it with my little hand pump. By the way, if you are interested in any of the tools I use, I have links in the description. I also have merch. Some merch if you want to get, you know, like a hoodie like mine, or a t-shirt, or a coffee mug. I do plan on making more designs here in the near future, but right now it's just my logo. Thinking of making some repair related like meme type shirts later. Okay, so this looks like it's making good contact. Kind of hard for you guys to see, but the filter is making some solid contact to the board. So best way to know is it making good contact is with your multimeter. So basically my meter is always in diode mode. I'm gonna go ahead and just diode mode the filter. So my red probe is on ground, which is the NAND, the metal, the metal surface of the NAND on the outside. So if you remember, the right side was getting a good reading, so 450-ish, that's fine. Now the real test is the left side. Okay, that gets a good reading. So we're making progress. Now, I guess I misspoke. This is the real test. We get a reading here at the connector. So red probe on Trinity, here on the screw post, and then second one on the connector. Yeah, there you go, 463. So remember the second one was giving us OL. Now we get a reading. So if we just go back to ZXW, go to the front side. Crap. And then, yeah, so we should get 504 on the second pin from the right. So first pin 589, we get 568. Second pin we get 469 when it should be 504, so that's fine, and so on, right? So usually what I do is actually I just listen for that beep. Can you guys, I don't know if you guys can hear that. But in most, like 90% of cases, your issue is either an OL or a short. So if you have a reading on the screen, so like 5 somethings, 4 something, whatever, and you get a beep, like a short beep, then you know it's good. So good, 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 silence. But it's supposed to be silent with OL, so that's fine. So then you go good, 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 silence. Okay, that's expected. Now that one's short. I'm probably measuring the ground pin. You know, that's kind of my method. If I go through that and I don't find any issues, then I'll go back and recheck them and actually look at the numbers to see maybe there's one that's like slightly off. That could be the issue. But here in this case, I think we are good to go. So let's go ahead and reassemble real quick. Wow, 46 minutes. Hold on, let me take off this foam because it gets in the way. I really hate this foam stuff. Since I had it on the preheater, you guys can see how it's kind of wrapping around the connector. That's why I always take them off. Alright, let's go back. By the way, if you're watching, how often have you guys seen backlight issues? If you're here on the chat, let me know. If you're watching later on the replay on YouTube, let me know in the comments. I haven't figured out how to get the live chat to show up later on the replay. For some reason it doesn't show up. Alright, so I'm plugging in the screen. Oh, you know what? This screen is all, this camera is messed up too. I'm gonna reset it. Alright, cool. Alright, so I'm plugging in. Alright, very important. Leave the battery disconnected until the very last step. So plug in the screen. Oops. Oh, it's not sitting right. It's hard to do while holding it up. Alright, screen is plugged in. So right now I'm just doing a quick test. So just screen, charging port, power button, and battery last. And then if you look at my USB meter here, let's go ahead and stop. Alright, so start the charts. So I plug it in. You see charging is going up and up. And look at that. We have an Apple logo, we have backlight. So see on this screen you can't really see, you kind of see there's a backlight here in the gap between the frame. Kind of hard to show you guys, but now it's working. Look at that. So that's kind of how you fix it. This is my test screen, so the home button doesn't work because the home buttons are paired. But you can see it's you know, touch is working. Trying to see how to show you guys. There it goes. Touch is working. You know, screen turns on and off. So there you have it. I mean, if you guys have any questions on any of this diagnosing, you know, how to use diode mode, how to, you know, how to use GXW or anything like that, just let me know in the comments. I'll do my best to answer you. But if not, hope you enjoyed the video. We're 50 minutes in. If this was a real repair that I didn't stream, probably would have fixed it within, you know, 5-10 minutes. But you know, these backlight repairs are pretty easy. You know, TriStar, which I just did the other day, is pretty easy as well. and you know, they're pretty common. So definitely worth you know, practicing these type of repairs, getting familiar with your multimeter, and just you know, watching more videos. If you're still having trouble you know, trying to figure this stuff out on your own, I am part of a microsoldering course. It's a 90-day program. It is basically an online portal where we have, you know, like a whole, like from step 1 to 100 as far as how to start soldering. If you know, and then on top of that, we have 2 calls a week, Zoom calls, where we go over different techniques. We do Q&As with all the students, and it's you know, we share a lot of information, you know, for troubleshooting, diagnosing, you know, how to do this, how to do that. So, you know, check out the links in the description. There's, you know, all the different, you know, my recommended tool list, the course, you know, to find out more about the course, my merch. So if you want a sweater like this, but yeah, if there's nothing else, I'm gonna go ahead and end the stream. And thanks everyone for watching. I'll see you guys in the next one. Goodbye.